Hi all. In this session, we are going to cover voice over a new radio or VoNR, mobile originating or MO call flow. So, unlike OTT, like over the top apps like WhatsApp or Skype, which normally depends on the best effort internet. So, carrier grade voice requires some guaranteed resources, and this flow shows exactly like how the application layer, you can say the IMS core, communicates with the transport layer or 5G core to guarantee that voice quality. So we have divided this call flow in phases. So in phase 1 we have the SIP invite, and that is over the default bearer. So suppose the user hit dial. Okay, at this moment there is kind of no dedicated voice channel, and UE is going to construct the SIP invite message containing the SDP offer, and it is proposing like audio codecs like AMR wideband and its IP and port info. And here the SIP signaling is treated as a standard data. It travels over the existing default PD session, which is kind of mapped to 5QA5, which is like specifically designed for IMS signaling. So it flows from UE through G node B through UPF and ultimately like lands at the PCCF, that is proxy CSF in the IMS core, and which forwards it to the SCCF and test to begin ringing in the far end. So at this stage, like the 5G core has no idea, like this is a voice call. As far as the UPF is concerned, it is just like passing that UDP and TCP packets to an external server. So now the next phase is the like QoS authorization and like the resource request. Now the IMS core, okay, like the specifically the PCCF inspect that particular SIP invite message, and it sees that the user want to set up an audio stream and that requires guaranteed bandwidth. So the IMS core cannot allocate a data resource itself, so it must kind of ask for like a 5G core for that. So now there is RX or N5 interaction like come into picture. So PCSF is going to send the authorization request to the PCF, that is policy control function in the 5G core. So in 4G core or diameter, this is the RX interface. In 5G core, we have N5 interface, that is policy auth create. Now the PCCF tell PCF I need a voice channel. It need 5QI1 kind of guaranteed bit rate for voice, and here is my kind of bandwidth requirement for that particular flow. Now PCF is going to approve that and pushes like no PCC rules, that is policy and charging control rules, to the SMF, and it instructs the SMF to establish a dedicated kind of QoS flow with the 5QI1 and ARP1, that is allocation retention priority, and also like GBR, that is guaranteed bit rate. Okay, and like after that it will be getting that notify response back for that particular update request. And now we have next phase, that is kind of PD session modification, or you can say initiation. Now like here SMF has its order from the PCF, and also it must now execute them across the user plane and the access network. So first like SMF is going to use N4 session modification request to tell the UPF to open the new pipe. So it install new PDRs, that is packet detection rules, and QERs, that is QoS enforcement rules to the UPF, like knowing like how the UPF so like UPF knows like kind of how to identify the incoming RTP packets, and how like UPF is going to treat them with priority. Okay, and after that in the next phase, in the next message, like SMF bundles the N2 and N1 messages, and it is going to send them to AMF via NAMF communication N1 N2 message transfer. Here like the N2 components tell like the G node B to allocate dedicated radio resources for 5QA1 flow, And N1 components, that is NAS message, goes all the way to the UE and telling the phone like your dedicated voice barrier is ready. You can now start sending audio packets on this new QoS flow. Now, once this is complete, the actual voice media packets like RTP will flow over this newly created tunnel, while the SIP signaling remains on the default 5QA flow. So here we have some important troubleshooting tip. Like if suppose like customer complained about some one-way audio or dropped call immediately upon answer, so we have to answer like QoS authorization and like this modification initiation. Okay, like in some cases N5RX interface is misconfigured, or in some cases like G0B may reject the N2 request due to like radio congestion admission control failure, and also like dedicated bearer will fail to establish. Okay, in that case the SIP signaling will still work perfectly and the phone rings, but the media path will never be created, and so like resulting in a silent or kind of dropped call. Now next move to phase. Now in the last slide, okay, we looked VoNR call. We saw like how IMS core ask the PCF for your voice resources, and we also saw and the SMF receives the orders to create dedicated 5 QI QS flow. Now the SMF has the policy. Okay, but a policy is just a set of rules. Now we will see like how these rules are translated into physical radio and like transport resources. Okay, which is like ultimately leading to customer saying kind of first message hello. So again, we have the first phase, like a dedicated voice bearer establishment. Now here, the SMF must now orchestrate the access node or G node B and the user plane to build the dedicated voice channel. Okay, so now the AMF is going to send NGAP PDU session resource modify request to G node B, and this message contains the crucial kind of N2SM information that involves 5QI1 QS profile. Now the G node we cannot just send the data. Okay, so it must allocate a physical kind of airtime. So it is going to send RRC reconfiguration message to the UE, that is, and kind of instructing the phone to set up a new dedicated radio bearer, that is DRB, that is specifically tuned for that particular voice traffic. Now the UE is going to reply with the RRC reconfiguration complete message. And once that radio link is established, the G node B is going to send N3 tunnel endpoint identifier back to the AMF, and which passes further to the SMF. Now the SMF take this G node B TEID and send an N4 session modification request to the UPF, and the UPF's forwarding action rules, or that is FAR, are going to be updated, and the N3 GTP tunnel is now locked between, you can say, end to end. Now in the second phase, we have the SIP handshake and the call connection. So now we can say the transport layer is ready, so we can proceed with the application layer. Now we have to here it is critical to note that we have the 180 ringing, 200 OK neck, and this message does not travel over the 5 QI is equal to 1 bearer. Okay, these are continue to write on default 5 QI is equal to 5 signaling bearer, and after some time the terminating network send 180 ringing. Okay, now here the caller, here the ringback tone, and now the called party kind of picks up that phone, and for that it is going to trigger that 200 OK message, which contains the final SDP answer, which is confirming the agreed kind of audio codecs. And after that, like the originating UE sends an ACK message to acknowledge the connection, and like here the control plane setup is kind of 100% kind of complete. Now in the last phase we have the bidirectional media flow. Now here the users are kind of speaking, and here the voice is digitized kind of into RTP, that is real-time transport protocol packets. And unlike the SIP signaling, like these packets are kind of injected directly in the dedicated DRBs over the air interface, and like these are flows directly over the GTPU N3 tunnel to the UPF. And because of this specific path is tagged with 5QI1, now the routers and the radio schedulers guarantees that bit rate and prioritize these packets over almost all other traffic, so that like you get the crystal clear audio without any jitter or delay. Okay. Now a common scenario arises like when you see in the trace analysis, like what happens, like if you see like you have 200 OK messages arrive the UE before like Gnode we finish that RRCG configuration for the dedicated bearer. So in, like this is kind of a race condition, and if the application layer connects before the transport layer is ready, in that case user might say hello, but those first few RTP packets, like they are going nowhere, okay, and are kind of going to drop. So in that case, like resulting in clipping at the start of the call. This is why like the tight latency and optimize NGP signaling between the AMF and Gnode are kind of absolutely critical for a premium, you can say, voice on over NR experience. And I think that's it from this particular flow. I will see you in next session. Thanks.